Hey everybody, in this video we are introducing the physics word momentum, probably a word that you've heard outside of a science context, but we're going to see the definition. This is probably going to be a shorter video. To be honest, we'll spend more time on how momentum is applied when we have multiple objects, okay? So momentum all by itself has a pretty simple definition. Momentum for an object, it is equal to the mass of the object multiplied by its velocity. It's an equation. There's two weird things about this equation for momentum. The first thing is we don't use the letter m to represent momentum. M is already used in physics for mass. We don't want to repeat the same letter, otherwise it'll make our equations confusing. So instead of using m for momentum, we use p. So momentum, symbol letter p, is equal to mass times velocity. Oh, look at this. M times v, not the toughest math equation that we've seen in this class, okay? That's our definition. The other thing that's a little weird is that momentum, just like time, just like force, just like velocity, it can be measured, which means we have a unit. We have a way to measure it. We use seconds for time, we use newtons for force. For momentum, the unit is simply called a kilogram meter per second. kgms. That's the unit. No other special name or symbol. Where is this coming from? Well, everybody, the unit has to match our equation. Look at the equation. Momentum is mass times velocity. Well, mass has the unit of kg. Velocity has the unit of ms. So that has to be the unit of momentum. This is what an equal sign means. This is equivalent to these two things multiplied. So momentum has a unit of kilograms, meters per second. That's exactly how you'd say it. Kilograms, meters per second, okay? Now, more conceptually, momentum is often linked to this idea of inertia, and we gotta be a little careful. While I have an example definition that uses the word inertia, inertia is not the same thing. Inertia is something that all objects intrinsically have in our universe. And whether I am on Earth or on the moon or in outer space, I have the same amount of inertia. I have that same amount of mass, the same amount of stuff that's inside of me. Momentum, though, is kind of like when you're looking at the inertia of an object when it's moving. Notice, if an object has zero velocity, it has zero momentum, okay? So momentum is kind of like inertia in that, if you're moving fast, it's difficult to stop. If you're really big and chunky like a train, you're difficult to stop. That's very similar to inertia, but momentum only cares about really when objects are moving. That's why a common, though not really a technical definition for momentum is, it's the inertia of an object in motion, okay? Another way to think of momentum is like the oomph of an object, okay? A linebacker charging, oh man, they have a good amount of weight on them. They're charging, hunting down that quarterback. They have a lot of oomph behind them for them to maybe make a tackle. Same thing for a train. Though it is worth noticing that momentum, because it's also based on mass, even if a train is moving slowly, even if it has a small velocity, it could still have a lot of momentum because things like trains have a huge amount of mass. So again, even a slow moving train is difficult to stop. Why? In a prior video, we talked about it in terms of inertia, which is true, but also a slow moving train has a lot of momentum, okay? Because it has a lot of mass behind it, all right? Now, team, later on, because this video is basically done, later on we're going to see how we apply momentum, because really what sets momentum apart, especially from things like inertia, is that momentum can transfer. The momentum of one object can turn into or can go to momentum in another object. And that is not true for inertia. Inertia is very much an individual quality of objects. But momentum, it turns out, can transfer. But we're going to do that in another video, okay? I think that's all I got for this slide. All right, thanks for watching. See you next time.